Math 1314, Tyler Junior College, Section 2.3, Linear Functions and Slopes. In the previous videos, we have defined the slope of the line, calculated the slope of the line, discussed the slopes of horizontal and vertical lines. We've discussed ways to write equations of lines. Normally, when you start writing the equation of line, you start with point-slope form because all you need is a point and the slope. We've talked about slope-intercept form, which is more compact and unique for a given line as opposed to point-slope form, which requires the slope but any old point you can find on the line. Slope-intercept form requiring the slope and the y-intercept. And we discussed how to graph a line given its equation in slope-intercept form by interpreting the slope as rise over run. But I want to go back to horizontal and vertical lines, as you can tell by the title of this video, equations of horizontal and vertical lines, and kind of give them a thorough treatment in terms of their slopes, their equations, and their intercepts. If you'll notice on the board, I have a couple of specific lines drawn. A horizontal line that has a y-intercept of 4, and a vertical line that has an x-intercept of 4. Now, we've already discussed the slopes of both of these. The slope of a horizontal line was 0. Because after all, slope is a measurement of steepness, and this is pretty horizontal. It has no steepness, either rising or falling. And if we picked any 2 points on the horizontal line, such as, let's pick 4, 1 and 4, 5, doesn't matter which 2 points we pick, the slope would be 0, except that those 2 points would not be on that line. Because 4, 1 would be over here, 4, 5 would be up there. So what would these ordered pairs be? Well, without labeling the x-axis, we can't specifically say what the x-coordinates are, but because they're all in the same horizontal line, I know the y-coordinate of this point is 4, and the y-coordinate of that point is 4. So maybe what I was thinking was 1, 4, and 5, 4, but honestly, the 1 and the 5 were arbitrary. The 4, however, is not. On this line, y must equal 4. In fact, I can pick any point, like back here, and I may not know what its x is. Over here it would be negative, but that's all I would know without more marks on the x-axis. However, because it's on the same horizontal line, y equals 4. It doesn't matter the point I pick. If I pick this point, y equals 4. If I pick this point, y equals 4, y equals 4, y equals 4. Guess what the equation of this line is? Well, what do all the points have in common? Y equals 4, and that would be the equation of this line. Notice that the equation doesn't care what x equals, because basically to get to this horizontal line, you can go left or right wherever you want, and when you're done running and stop, rise 4, go up 4, y equals 4. So what's the y-intercept? Well, the y-intercept is where it crosses the y-axis, and on this line, all the y's equal 4. So it makes sense that the y-intercept would be y equals 4, or as an ordered pair, 0, 4. But what about its x-intercept? Well, the horizontal line will almost always be parallel to the x-axis, and as a consequence, will never intersect the x-axis. So there's no x-intercept. No x-intercept unless what? What's the only way a horizontal line can touch the x-axis? Answer, if that horizontal line is the x-axis. So imagine for a moment that instead of y equals 4, we had y equals 0. Y equals 0 would be the x-axis. That's the equation of the x-axis, y equals 0. So there's no x-intercept, and I think this merits more of a parentheses than a comma, unless it's y equals 0, and at that point, every point is an x-intercept. Every point is an x-intercept. Now, you would rarely talk about that specific line and its infinite number of x-intercepts because every point on that horizontal line would be an x-intercept technically. So normally a horizontal line has no x-intercepts with the exception of the x-axis, which is all the x-intercepts. But what about a vertical Do you remember what we said about the slope of a vertical line? If we picked a couple of points on here, such as 4, 1 and 4, 5, which I should have not written over there, and we calculated the slope, we would run into a problem because the x's are equal. And in the denominator of the slope formula, you subtract the x's. Well, that would give us 0 in the denominator, making the slope undefined. The slope is undefined. Just a reminder, I do not prefer to say that it has no slope, because although that is technically correct, it is too easy to confuse the phrase has no slope with a slope of 0. This line has a slope, it's 0. This line technically doesn't have a slope, so we'll say its slope is undefined. So what do you think the equation of this vertical line is that hits the x-axis at 4? Well, if you were to pick any point on this line, what could you say about its ordered pair? You really couldn't say anything about its y, because the y's can go up or down as far as you want. However, every point on this line, the x-coordinate is 4. X is 4, x equals 4, x equals 4, x equals 4. Guess what the equation of this line is? X equals 4, which makes sense because this equation really doesn't care what your y-coordinate is. It just says go over 4, now go up or down as far as you want. Stop and you'll be on the vertical line. The discussion about the intercepts is just the same as it was before, except completely reversed. This vertical line does have an x-intercept, it's at 0, 4. But being a vertical line, it's parallel to the y-axis, and therefore does not have a y-intercept. Unless, no y-intercept. Unless your equation is x equals 0, in which case this vertical line would be sitting here, it would be the y-axis, and in that case, every point is a y-intercept in the sense that it's on the y-axis. You know, this is very specific. This is the horizontal line through y equals 4. This is the vertical line through x equals 4. I'd like to take these characteristics of these lines and make them a little bit more generic. So how do we make things generic? We take out specific values and replace them with a variable. In this case, I would want to take out this 4 and replace it with something generic. Well, what's a good something generic to represent a y-intercept? Oh, we already have something, b. So let's make this generic and say that the equation y equals b is the equation of a horizontal line, in which case its y-intercept would be 0, b. There would still be no x-intercept unless you have the equation y equals 0. And the same thing for vertical and x-intercepts. Typically when x-intercepts are discussed both in terms of x and y, b is used for the y-intercept, a is used for the x-intercept, because a comes before b in the alphabet. And so for a vertical line, the slope is undefined, the equation is x equals some number, we'll call it a. There's no y-intercept unless your equation is x equals 0, in which case every point is a y-intercept. But the x-intercept would be 0, a. So horizontal and vertical lines are actually pretty easy to summarize and describe. Their equations are very simplistic. Now, I must let you know that these equations can come in various forms. For example, this equation is y equals 4, but it could also be y minus 4 equals 0. That's the same equation, just written differently. Or it could be something like 3y equals 12. If we divide both sides by 3, we would get y equals 4. Or any equation that would solve to give y equals 4. Similarly over here, any equation that would solve to get x equals 4 would be an equation for this vertical line. So not too tricky once you figure out, hey, these are very simple equations.